Students, now we are going to start with the next type of questions. Again, observe carefully. In this type, if you observe the two questions which are written on the board, you can see that the power of the numerator, it is x square, and if you multiply these terms present in the denominator, you still get the power as 2, isn't it? X plus 2 into 2x plus 3, the power is going to become 2. So can you observe in the two questions which are written here, the power of the numerator is equal to the power of the denominator. Students, this is a very important type of question. So now, usually what happens is, many of the students, they always begin with partial fraction. Obviously, we are also going to begin with partial fraction, but there is one very important thing that you need to note over here. Observe, since the power of numerator and denominator is equal, if you try to make use of the method of partial fraction directly, what will happen? You will get a upon x plus 2, isn't it? A upon x plus 2 plus b upon 2x plus 3, that is what you'll be writing. So a and b are nothing but what? They are constants. So a upon x plus 2 plus b upon 2x plus 3. If you now do the cross multiplication, remember that a and b are constants, they are numbers. So when a multiplies with 2x plus 3, you get some new expression, let us say px plus q, isn't it? So 2x plus 3 multiplies with some constant a, only the numbers are going to change, nothing is going to happen to x. Similarly, when b multiplies with this x plus 2, b is again a number, it multiplies with x plus 2, only the numbers are going to change, the term of x remains as it is, its power is not going to increase. But in the numerator, you want x square. That means, students, this is what you need to pay attention for. If you directly write this as a upon x plus 2 plus b upon 2x plus 3, you won't be getting the numerator, which is x square. The reason for that is a and b are nothing but what? They are constants. When they multiply with 2x plus 3 and x plus 2, only the numbers are going to change and not the power. That's why, students, in this type of questions, you cannot proceed directly with partial fractions. Of course, we are going to make use of partial fraction, but not directly. So now remember this one very important concept. This is going to be true for this type as well as the next type that we are going to see, where the power of numerator is going to be greater than the power of the denominator. So here you can see that the power of numerator is equal to the power of denominator. So when this happens, what you should be doing? So power of numerator is equal to the power of denominator. So there are two different ways in which I can proceed further. I usually like the first method, which says that you should be arranging the numerator. So arrangement of the numerator to get the denominator. You should arrange the numerator in such a way that it should exactly get the denominator. Whatever is present in the denominator, every single term should come back into the numerator. So that is the very first method. And the second method, students, that can be used for the next type also. It says use polynomial division. Now, both the methods will fetch us the same answer. Both of them are going to give us the exact same answer. But then, using polynomial division is a slightly lengthy process. So, this method, using polynomial division, you make use when the power of the numerator is greater than the power of the denominator. When it is equal, you always stick to arranging the numerator to get the denominator. It is an easier method of getting the same answer. So we are going to solve one question from here. Let us say we take the second question. We have y is equal to x square upon x minus 1 into 2x plus 3. So let's proceed with this particular question, second one. So I have y is equal to x square upon x minus 1 into 2x plus 3. So what I'm going to do here is I'm going to arrange the numerator as if I get the denominator. So first of all, I need to open the brackets in the denominator. So this is the denominator I have, x minus 1 into 2x plus 3. I'm going to open the brackets over there. So I get here x square upon, let's open the bracket, so x into 2x that's 2x square, x into 3. So that's 3x, and minus 1 into 2x, that's minus 2x. So you have got 3x and minus 2x. So that gives me plus x, and minus 1 into plus 3 is going to become minus 3. So now look at the numerator, look at the denominator. You can see that the very first term in the numerator is just x square, and the first term in the denominator is 2x square. I want to make the numerator to look like the denominator. So what is the first thing that I'll need is, I should make this x square as 2x square. So what I'll do, I'll multiply and divide by 2, isn't it? So I'm going to multiply and divide by 2, students. Here I have this x square upon 2x square plus x and minus 3. That's my denominator. So I'm multiplying and dividing by 2. So that's 1 by 2, isn't it? So I multiplied and divided by 2. Now observe carefully. I've got 2x square. That was my first term. Now what more I need? I need plus x and minus 3. Now observe carefully. I'm going to put a bracket over here. Let's put a bracket. So that was 2 multiplication and division, isn't it? So 2 was multiplied in the numerator and in the denominator. So I've got a numerator as 2x square. Now let's write this plus x and minus 3. I need plus x, I need minus 3. So let's bring them. Now if I need this plus x and minus 3, how it can be adjusted? Observe carefully. So I write plus x. To adjust this plus x, I will need a minus x, isn't it? So plus x and minus x, it can be easily cancelled. You're left with 2x square. Then this 2 and 2 cancels. You are left with only x square. So the arrangement is what you can say, getting very easily over here, isn't it? So 2x square plus x minus x. I've got this plus x. The next thing that I need is minus 3. So let's get this minus 3 also. I've got minus 3. So this minus 3 will need an adjustment of plus 3. So you can observe that all the terms are getting adjusted over here. Plus x and minus x gets cancelled. Minus 3 and plus 3 gets cancelled. You are left with 2x square. 2 and 2 gets cancelled. You're left with x square, which is the original term. So you observe that x square now has been transformed into the terms where you can see this 2x square plus x minus 3 is nothing but what? It is present in the denominator. Now be very careful. You cannot directly cancel these terms. You also have minus x plus 3. So you need to again do some rearrangement. So observe carefully the next step. So I'm going to write 1 upon 2. Then a bracket. So there is a numerator which contains 2x square plus x minus 3. So I write 2x square plus x minus 3. That's my first term. And the next two terms which are left, minus x and plus 3, from these two terms I'm going to bring the negative sign common. So let's bring the negative sign common. So if I take out the minus sign common, what are you left with? You are left with x minus 3, isn't it? And then there is a denominator which is 2x square plus x and minus 3. Now what are you going to do with this denominator? This denominator will get separated with the two terms which are present in the numerator. So now my next step is going to be 1 upon 2. I do the separation. So I get 2x square plus x minus 3. Its denominator is also going to be 2x square plus x and minus 3. Then there is a minus sign. Then you have this x minus 3. Upon you have the denominator 2x square plus x and minus 3. So what cancels here? You can easily say this 2x square plus x minus 3 cancels. And now look at this next term. In this term, you see the numerator. It is x minus 3. So power of numerator is 1, isn't it? Look at the term in the denominator. Here you can see that the power of denominator is how much? It is 2. So power of numerator is less than the power of denominator. So whenever the power of numerator is less than the power of denominator, we can definitely proceed with the method of partial fraction. So for this part of the solution, for this part, I'm going to make use of the method of partial fraction. Here what has happened? These two terms in the numerator and denominator have cancelled, and you are going to get 1 over here, isn't it? So this is 1 upon 2, then a bracket, then there is a 1 minus whatever terms are present over here. I'm going to make use of the method of partial fraction to simplify those terms. So let's take this particular term, x minus 3 upon 2x square plus x minus 3. So I'm going to write here, consider x minus 3 upon 2x square plus x minus 3. Now 2x square plus x minus 3 is nothing but what? It was the simplification of x minus 1 and 2x plus 3. These are the factors. So let's write them. So I write here x minus 3 upon, you have x minus 1 into 2x plus 3. Now you can see that this is x minus 3 upon x minus 1 and 2x plus 3. You have two factors. So I'm going to separate the terms. So you are going to separate partially. I can say the partial factors are going to be what? A upon x minus 1 plus b upon 2x plus 3, isn't it? So let's do the cross multiplication. So you get a into 2x plus 3 and plus b into x minus 1. So that's a into 2x plus 3 plus b into x minus 1 whole divided by x minus 1 and 2x plus 3. Now, you know that this x minus 1 multiplies with 2x plus 3 is definitely going to be this term, isn't it? 2x square plus x minus 3. This and this are exactly same. So, the two denominators from the left and the right is going to do what? They are going to cancel each other, isn't it? The two terms present in the denominators, left and right, they are going to both cancel each other. So, what equation are you going to get over here? The equation that will be formed over here is a into 2x plus 3. I'm going to rearrange the terms, isn't it? Plus b into x minus 1. This is equal to x minus 3 is equal to x minus 3. I'm going to call this as equation number 1, isn't it? So now let's take the first factor, students. Who is the first factor? The first factor is x minus 1. So let's take x minus 1 equal to 0. So let's put x minus 1 equal to 0. That means x is equal to 1 in equation number first, isn't it? So wherever you see x minus 1, you take it as 0, and in place of x you put 1. So in place of x I'm going to put 1. So that's 2 into 1 plus 3. So that's 5. So a into 5 plus b into, what are you going to put x minus 1 as? X minus 1 is going to be 0. Again, if you put x as 1, you are still going to get 0 only, isn't it? So that's b into 0, and then x is taken as 1, so that's 1 minus 3, you get minus 2, so you get a as minus of 2 upon 5. A has come minus 2 upon 5. So that is when the first factor was taken equal to 0. Now let's take the second factor. Who is the second factor now? Students, the second factor is 2x plus 3, isn't it? The second factor is 2x plus 3. So let's take 2x plus 3 equal to 0. So I'm going to now put 2x plus 3 equal to 0. That means x becomes equal to minus 3 upon 2, and this I'm going to substitute in equation number first, isn't it? So let's put 2x plus 3 equal to 0. So if 2x plus 3 becomes 0, you get a into 0. So I write here a into 0 plus b into, what you're going to put x as? X is now substituted as minus 3 upon 2. Students, you're putting x as minus 3 upon 2. And then you have this minus 1. Isn't it? X is taken as minus 3 upon 2. And then you have minus 1. Do the simplification. So 2 into 1, that's 2. Minus 3 and minus 2 becomes minus 5. So you're going to get minus 5 upon 2. This is equal to, you have to do the simplification in the right also. What is x taken as? It is minus 3 by 2. So students, what is this going to become? It is going to become minus 3 by 2. X is taken as minus 3 by 2. Minus 3. So that's 3 into 2, isn't it? So that's 6. Minus 3 and minus 6. That's minus 9. Minus 9 upon 2. So I write here minus 9 upon 2. So now you can observe a into 0. Obviously it is going to become 0. So that term goes from there. You can definitely say the 2 and the 2 can be cancelled. The negative sign also gets cancelled. So you are left with b. And b is going to come 9 upon 5. So I've got b as 9 upon 5. So I've got the values of a and b, isn't it? So x minus 3 upon 2x square plus x minus 3 now can be written as a upon x minus 1, where a is how much? Minus 2 by 5, and plus b upon 2x plus 3. What's the value of b? It is 9 upon 5. So let's write that term also. So therefore, x minus 3 upon 2x square plus x minus 3 is going to become what? It is going to become equal to a, which is minus 2 by 5, upon x minus 1. So a is minus 2 upon 5 upon x minus 1. And then students, plus the value of b, which is 9 by 5, So I write here 9 by 5 upon, you have 2x plus 3. So this is the simplification of the term x minus 3 upon 2x square plus x minus 3. That means it is a simplification of this term. So what does now y become equal to? So I can say, therefore, y becomes equal to, you have 1 upon 2 outside the bracket, you can observe, isn't it? This entire step has this 1 by 2 outside the bracket, into this term has given me answer 1. So I write 1. Then be very careful. You should be extra careful when there is a negative sign. Look at this, there is a negative sign. So you take care of the terms which are going to come ahead of it. Remember that the negative sign will always change the sign of the terms which are going to come ahead of it, isn't it? So this is the negative sign. You can see this particular term over here. This term has simplified into this over here, isn't it? So look at these terms. What the sign you have here? Here it is a negative sign. Here it is a positive sign, and you can see that there is a negative sign over here present ahead of this particular term, whose simplification is written over there. So this negative sign will do what to those terms? It is going to change the sign of those terms, isn't it? So those terms will now be written as 1. This was 1. Minus and minus becomes plus 2 upon 5 upon x minus 1, and the same negative sign changes the sign of the next term also. You get minus 9 upon 5 whole divided by 2x plus 3. This is what your simplification is. Now what you can do is, again you can take this 1 by 2 and you can multiply it inside the bracket. So y becomes equal to, you get 1 by 2, then plus this 1 by 2 and this 2 by 5. So the 2 and 2 cancels. You get simply 1 upon 5, isn't it? 2 and 2 cancels, you get 1 by 5, and you have 1 upon x minus 1. Then minus of this 1 by 2 multiplies with the 9 by 5. You get 9 by 10 into 1 upon 2x plus 3. This is what your y is in the simplified form. And students, I hope you all remember that if y is 1 upon ax plus b, then the nth derivative, you got to remember all the formulas very properly. So yn, the nth derivative is going to be minus 1 raised to n, a raised to n, n factorial upon ax plus b raised to n plus 1. That's the value of yn, the nth derivative. So let's use it over here. So I'm going to differentiate this n times, isn't it? So let's differentiate n times. So what happens? You get yn. What's your first term? The first term is 1 upon 2. It's a constant term. The very first derivative is going to come 0. So the nth derivative obviously comes 0. So no need to write the nth derivative of 1 upon 2. Next term, if you observe, 1 upon 5 is a constant. So I write this 1 upon 5 as a constant, and I have 1 upon x minus 1. This is like 1 upon ax plus b. Ax plus b, a is 1, b is minus 1. So use the formula. So I can get here minus 1 raised to n into a raised to n. So a is 1 here, 1 raised to n into n factorial upon x minus 1 raised to n plus 1. So that's the nth order derivative of the very first term over here, 1 upon x minus 1. Then you have minus 9 by 10. So write minus 9 by 10, again a constant term, isn't it? And 1 upon 2x plus 3 is again 1 upon ax plus b. Here the value of a is 2 and the value of b is 3. So 1 upon ax plus b. What I'll be getting here? I'll be getting minus 1 raised to n into a raised to n. So what's the value of a here? It is 2. So I get 2 raised to n into n factorial whole divided by ax plus b, which is 2x plus 3 raised to n plus 1. So that becomes your answer, students. So did you observe in this particular type what have we learned? We have seen that whenever the power of the numerator is equal to the power of the denominator, what you should be doing? You should be adjusting or arranging the numerator in such a way that you should be getting the denominator as it is back, isn't it? So whatever you find in the denominator, all the terms which are present in the denominator should exactly repeat in the numerator also. This is called as arranging the numerator to get the denominator. Of course, we will have the other method using the polynomial division. This we are not going to learn in this particular type. We are going to take another question where the power of numerator is going to be more than the power of denominator. There we will understand how to make use of polynomial division, which can be used in this particular type as well. So students, I have solved the second question for you, isn't it? Now the first question that is written on the board becomes a homework. Make sure that you solve it very properly. That was all about this particular question. Now we are going to move ahead with the next type of questions.